Good afternoon, grade 12s. Welcome back to Smart Teaching Online, proudly sponsored by VT Africa, Holdings, Fibotech, and Vastra Tech. In order for you to be part and parcel of today's lesson, you have to log in to www.hellosmart.com. In order for you to be part of today's lesson, you have to log in to www.hellosmart.com to take part in the assessments. Sign up as guest, type in your class ID. Your class ID is 598751. I can repeat this. Your class ID is 598751. Add your name. Add your name. Thank you. So today we're going to carry on with the work. This is where we have started last time. Yesterday we were busy with work. Today we have to finish our work. So what I need you to be ready with, I need you to have a calculator, have a pen, have your own smart technology, a smart device. As you can see, yesterday we have covered the positive. Today we are going to cover the zero work, negative work, and determine some of the problems on inclined and horizontal. Okay. Firstly, I need you to understand the following. When we talk about zero work, there's nothing happened. In other words, the force that has been applied to an object has nothing impact. There's no impact on it. Okay, zero work occurs if the angle, I need you to take this into consideration. The angle between the force and the direction of the displacement of the object is exactly 90. If it's exactly 90, you know that you are not going to get any work. All right. What are they talking about? What are we talking about when I'm saying exactly 90? If you can just look at the force vertically and displacement in the horizontal is between the x-axis and y-axis, or horizontal or vertical line. Those arrows, they are showing us where the displacement is going. If you can just look at the angle in the middle there, we have theta equals to 90 degrees. The moment you have that, you must know that you are not going to have any work at all. Why? Cos 90 is equals to 0. Cos 90 is equals to 0. Okay, 0 work will be done on the object by the force in the direction of its displacement. All right, I need you to look at this. If we have a force, all the forces are perpendicular to an object displacement. They're not going to give us any work at all. Why? Because the angle is equals to 90. All right. Let us look at the example. If you can just look at this, we have Sam. Sam is walking to her car with a shopping bag. That is a bag there on the right hand side. In her hand, her car is 3 meters in front of her. In other words, we have to write down what is given so that we can just look for what is not given. Okay, we have 3 meters, that is the displacement. And now the applied force is 100 Newton of the shopping bag is perpendicular to the direction in which she walks. The moment you see perpendicular, you must know that we are going to have an angle. We are going to have an angle. The angle there, let me say the angle theta. Let me go back. Okay, I have to write down the data. That is a given information. What do we have there? What is it given? We have change in x, which is equal to 3 meter. We have applied force. It's going to be indicated by FA, an arrow, half an arrow on top, which is equal to 100 Newton. And what else? And theta, which is equal to 90 degrees because of the perpendicular. Okay. What else? Let me extend my page. What else? We are looking for work done. We don't have work. We have a displacement, we have a force, applied force, we have theta, we have 90 there, but we don't have work. We have to calculate work done by the force. All right. What I need you to do, I need you to go back. I need you to go back and look at yesterday's work. I gave you the formula of work. If you can just look at it, we have W. Let me erase this. Let me choose another pen. Okay, we know that the formula of work is W is equal to the force applied, W is equal to the force applied, change in X, cos theta. I will extend it again. Okay, what do we have? We have to substitute whatever that is given to our formula. We have applied force, which is 100 Newton. And then displacement, we have 3 meter there. That is 3 meter. And then cos, your theta is 90 degrees. As we carry on, we have, I need you to do calculations while I'm doing mine. That is 100 multiplied by 3 multiplied by cos 90, which is equal to 0 Newton meter, which is equal to 0 joules. I hope we are still together. I hope we're still together. Let us Look at the worked example. If you didn't get it right, I need you to redo it. Maybe it's a problem of your calculator. You have to learn your calculator first, because it's going to happen even in the exam room. If you don't understand your calculator, you're just going to have some problems. Okay. We are done with the zero work. We have to look at the negative work. When it comes to negative work, it's going to be done. Even here, we're just going to look at the angle. Angle is the one that is going to tell us whether it's negative, it's positive, it's zero. As we explore here, I just want to highlight some of the key points that we're supposed to bear in mind. This network is done if the angle theta between the force and the direction of the displacement of the object is greater than 90 degrees. In other words, the moment you see this angle and this greater than 90, you must know that it's going to give you a negative work. In other words, energy is going to be removed from that object and transformed or transferred to other forms of energy. You have to ask yourself, what are these other forms of energy? We can this energy can be transferred to heat, can be transferred to sound as well. If you can look at the diagram here, we have this angle. The angle, of course, is greater than 90. Angle is greater than 90. That is 150. What about the force? The force, if you can look at it, is pointing to the other direction. And these displacements is also pointing to the other direction. All right, look at the distance covered. And the angle that we're talking about is from here up to there. That is why we have 150 and is greater than 90. If you want to understand the negative work, the moment you see your angle is greater than 90, is greater than acute angle, you must know that this is the negative work. What you're going to get there, you have to expect a negative answer. Okay, let us look at the example. Let us look at the example. Cedric takes his dog, Jax, for a walk. Jack spots a cart and starts to pull on his leash. Cedric applies a force of 100 Newton at 125 degrees to the horizontal for a distance of 3 meters against the pull of the dog. I told you earlier that the moment you come across with a question, I need you to write down the given information so that they can just help you. This information is going to help you to calculate what are they looking for. What is it given here? I'm going to highlight them so that we can just carry on together. All right, let me start with this. We have been given applied force, which is 100 Newton. Which is 100 Newton. We have given something else again. This is 125 degrees. That is the theta. And what else? If you can look at the distance, we have 3 meters there. Okay, what is again given here? We have to calculate. This work done is also given, but it's what we are going to calculate. Okay, let me extend my page. Let me extend my page. Of course, what I'm looking for is just that it takes a while to take us back. Okay, here we are. Now, I told you to write down the given information. It's called data. This is very, very much important because it's going to help you. Which formula are you going to use? Where are you going to substitute? And what is it going to happen after substitution? What I need you to do, we have been given applied force. This is very, very much important. I need you to write it down. We have 100 Newton. That is the applied force. Don't forget to indicate that this applied force is a vector. We also have theta. We also have theta. Theta there is 125 degrees. It's also 25 degrees. Okay. And what else? And what else? Let us go back. Okay, we have a distance, change in x, which is equals to 3 meters. Okay. If you can just look at that, we have to calculate the work done. This work done is also given. Let me put it down. W is equals to unknown. Okay. This is what we are going to work out. Let us move fast. We have to go back to our formula of work done, which is W is equals to the force applied. The force applied. The force applied, change in x, cos theta. Cos theta. Okay. Let us substitute our values to our formula and see what we are going to get. Then force applied is 100 Newton multiplied by change in x is 3 meter there. Cos of, let us go back and check. What do we have? Cos of 125 degrees. Okay. Let me extend my page so that we can have a space. Okay. Let us calculate this. While I'm doing this, I encourage you to do calculations as well, so that you can see whether you are getting it right or not, even for the sake of knowing your calculator. All right, we have 100 multiplied by 3 multiplied by cos 125 degrees. I got minus 172 Newton meter, which is negative 172 joules. Don't forget, this is very, very much important. Work is going to be measured in joules. I need you to compare my answer with your answer. Okay, let us check here. I need you to look at this. We have 172 joules. We have to follow all the steps because the moment you write the formula, there's a tick on it. When you substitute, there is also a tick. I need you to do what I'm doing so that you can't lose a mark. Okay. We have another example here. We have another example. This is the exercise that I can just say, I'm giving you 5 minutes. Let me give you 5 minutes to do this. Farmer Joe is trying to move his donkey. The donkey applies a force of 200 Newton and refuses to move. The 200 Newton force acts in the opposite direction to the displacement. Thus, the angle between the force and the displacement is 180 degrees. The magnitude of the displacement is 3 meters. Okay, calculate what is the work done by farmer. In other words, you have to calculate the work done. If you can just look here, we have multiple choice. We have A, B, C, D. So these ones, if you do calculations and get something different from this, you must know that you are wrong. Your steps, you have to go back and redo it again. Okay, I'm just giving you 5 minutes. I'm just giving you 5 minutes to do that. Remember, while we're busy writing down or doing some calculations, firstly, I told you to write down the given information in order for you to get to the unknown. Okay. 4 minutes left. 4 minutes left. If you don't have a device, I advise you to write down the given information, write everything so that you can just have something to refer on while you're doing your revision. Three minutes left. 3 minutes left. Let me extend the page so that we can work out with you. Two minutes left. 2 minutes left. 2 minutes left. A minute left. A minute left. A minute left. A minute left. Time up. Okay. Hopefully you have done. Let me highlight what is given and write down the data. Like I said, we have applied force, which is 200 Newton. And then we have an angle. Our angle there is 180 degrees. We also given the displacement and work done. Okay. If you can just look at that all the time, you have to write down your formula of work done because it's very, very much important. You can't just start somewhere else. You have to start where your formula is. Firstly, you write down the data. What is it given? We have applied force. We have applied force, which is equal to 200 Newton. And what else? And what else? We have angle theta, which is equal to 180 degrees. What else? We also have displacement, that is change in x, which is equal to 3 meters. Lastly, we have been given also W is equal to nothing. We are going to work out the work done. Now we have to go back to the formula of work done. Work done is equal to the applied force multiplied by the displacement multiplied by the cos theta, which is equal to, we have to substitute. For substitution, before we substitute, let me extend my page and have enough space. Okay, we have applied force there, which is 200 in newtons. We have displacement of 3 meters. We have theta there, that is cos theta is 180 degrees. Okay, if you can just look at it, I need you to use your calculator. Let me do it quickly for you. That is 200 multiplied by 300 multiplied by cos 180, which is equal to minus 600 newtons meters, which is equal to negative 600 joules. Okay, in other words, the work done by Joe is equal to negative 600 joules. In other words, this is called a negative work. Okay. I need you to mark yourself. I need you to mark yourself all the time. If you are wrong, don't erase. Just do a correction so that tomorrow you will get it right. Okay. The answer there is A. The answer is A. Okay. Hopefully we are still together. All right. I don't want to waste time. I have to move a little bit faster. Like I said, we're going to look how to determine the network. When it comes to net, I need you to remember this. A net, we're supposed to have two forces that they're acting towards the same direction or different direction. It's where you can just get the net. You can get the difference or you can get the total. If they are going to the same direction. Okay, the same work, we are still going to use the same formula of work done. This time, we are going to use the net force because we have to look all the forces that are acting on a particular object. We have to show them. Either you can use the free body diagram or you can use let me show you something. Free body diagram or force diagram. If you can look at this diagram here, we have a car, we have inclined. This is the plane that I'm talking about. Of course, we have forces. I need you to think about the frictional force. I need you to think about the normal force. I need you to think about the applied force. I need you to think about the weight. I need you to think about F perpendicular. Okay. If we have this angle here, is going to give us the direction. Earlier we talked about the positive work, we talked about the zero work, we talked about the negative work. This time we have to calculate all the forces that they are just taking part here. We have to ignore those forces that are coming down and the normal. We have to look at the x-axis. X-axis I'm talking about this plane here, inclined surface. All right. Whenever positive network is done on an object, the energy of the object will increase. In other words, the car or any object will keep on increasing speed, keeps on increasing speed. Okay, to determine network done, determine the positive and negative. Like I said earlier, we're just going to have forces. After those forces, we can just go to the work done, then find the difference between the two. Like I said, if all the forces, they are, the other one is going up, applied force, the other one is going down. Of course, we have a friction that is always opposing the motion of an object. We are going to get the difference between the applied force and the frictional force. Of course, we have done these frictional forces in grade 11. I need you to recall what we have done in grade 11 so that we can move together. This network done is going to be denoted by the capital letter W and sub of, let me highlight it. I'm talking about this. It's going to be denoted. This network done is going to be denoted by capital letter W, sub of net. The moment you say it like this, you must know that we are going to use the F net as well. If we have W net, we are going to use F net instead of an ordinary applied force. Okay, there are few steps that we're supposed to follow. I need you to look at the first step. The first step, draw a force diagram. Like I said earlier, you can use a force diagram or you can use the free body diagram. In the exam, they will tell you to use force diagram or free body diagram. How do you know that this is the force diagram? You are just going to have an object, and that object, you have to indicate all the forces that they're acting there. Okay, when it comes to, let me extend this page so that I can explain. All the forces. Suppose I have a box at rest. It's not moving at all. It's not moving at all. If it's not moving, this is your box. Or you can say this is our object. This object here is going to have a normal force, is going to have a downward force. This one is going to be indicated by capital letter N. That is the normal force. Here we are going to have what? This is the weight. If you can look at this horizontal plane, we are just going to have only two forces, the normal force and the weight. All these two, because this object is not moving, the work done there is equal to 0. And this normal force is perpendicular to our object. Also, this one is also perpendicular to our object. Okay, these are the forces, force diagram. I'm trying to explain the force diagram. These are the forces that we have on this diagram. What about the free body diagram that I'm talking about? You're supposed to have what? You're going to have a dot. This is a free body diagram. In other words, you're just going to have this line. Here, you can just have it up there or can have this down. This one is the normal force. This normal force can be denoted by capital letter N, or you can use the F sub of capital letter N. When it comes to weight, you can use W for weight, or you can say is Fg, that is the gravitational force. Don't forget, we have different authors, different textbooks. Some of the textbooks they use N, some of the textbooks they're using F sub of N. It's still okay. Others they're using W. Don't say, my textbook, we don't have N. My textbook, I don't have Fn. I don't have W, I have F of G. It's the same. Okay. If you can just show all the forces we still have on the horizontal. What about the inclined? What about the inclined? Let me extend the page. Under inclined, I can just say we have this inclined. This is a rough surface. If it's a rough surface, I have an angle here, which is 30 degrees. We have this object somewhere here. That object, we have this applied force. Is going up the hill. Okay. What will happen? We are going to have what? You have to show all the forces that they're acting on this object, on an inclined surface. You have to show the normal. The normal supposed to be perpendicular. If you can just look at that, you have F of G perpendicular. F of G perpendicular. If you can look at that, we are going to have, because it's a rough surface and there is an applied force going upward, we are going to have what? A friction. That is a kinetic friction, denoted by F of K. Small letter f, sub of K, this one indicates that this is the kinetic frictional force. All right, what will happen again? Because of this angle, we are going to have what? We are going to have a weight. Let me just pass here so that you can see. You can just have, let me use W. If I use W, I suppose to use W as well that side, so that you're not going to be confused. Okay. I'm going to have what? If you can just look at this angle, we are just going to have something else there. Okay. In other words, here we are going to have a W sub of perpendicular. In other words, is W. Just a moment. Just a moment. I'm still waiting for the pen. Waiting for the pen. Okay. While I'm still waiting for the technology to bring back our pens, we must bear this in mind. The moment you have this dotted line indicates the W perpendicular. In other words, that is perpendicular to the surface that we have here. And this number, if you can look at that, we have N, which is equals to W perpendicular. It's back. Okay. That is W perpendicular. If you are using W here, you have to use W perpendicular there as well, so that you are not going to confuse yourself. If you are using the Fg here, the gravitational force, you have to use also Fg perpendicular this side. Because I'm using W here, I have to use the W perpendicular there as well. Okay, if we can look at that, we have this angle. In mathematics, they taught you the angle there is 30 degrees. The angle there is 30 degrees. In mathematics, they showed you that if you have C somewhere here, you have A here, you have B there. This, let me explain this because most of the learners, they get confused. They memorize that, okay, we're supposed to have, it's a must for it to be there. It's not like that. It has been worked out. Okay, if you can just look at the angle A, we have angle A there plus angle C, which is equals to 90 degrees. I need you to understand this 30 here. Okay, we know that A, we have, let me say C is equals to 90 degrees minus angle A. For angle A there, we know that, let me extend that. Angle A is equals to what? If we have 30 there, we have 60 there, so that we can just have 90 here. Is that clear? Okay, we have 60, we have 30. Of course, I have to do what? I have to say 90 degrees minus 60 degrees, which is equals to 30 degrees. That is the 30 degree that we have there. If you can look at that, this is very, very much important. I need you to go back and revisit your trigonometry. Okay, now I have to show you. We have this. This one is parallel to the surface. If you can look at it, this line here is parallel to the surface, and even here, we are going to have something here. We have friction, frictional force, kinetic friction, and then we have W parallel. What is it parallel there? This one is parallel to the surface. If you can look at that, this W here is parallel to this surface. Now we have the frictional, kinetic frictional force. We have a parallel force. We have a weight. We have the weight perpendicular. And we have a normal force there. Let me just use N, not Fn. Okay, if we can look at that, we have what? Your N here, your normal force, is equals to W perpendicular. W perpendicular. Okay, if you can look at that, we have a W sub of perpendicular. These are equal. All right. What will happen here? If you are determining them, you are just going to have what? You are just going to have two arrows that they are showing that they are going towards one direction. In other words, we are going to have what? A total. Total downward forces, which is equals to W parallel plus kinetic friction. Don't forget, kinetic friction is small letter sub of K. Okay, that is downward. If you can just look at this, we have two. Okay, thank you very much. We shall continue here to carry on with the steps tomorrow. Thank you very much. See you tomorrow.